The picture plane. A window solves perspective problems. Drawing on air isn't easy. That's why we draw on a kind of window. Something flat to display that delightful illusion of three-dimensionality with which the world is so rife. But the picture plane is more than that. It's a window that explains how perspective works. The picture plane shows us from the top why a close object looks wider than the same object farther. That's a truth of how we see. Closer makes bigger. This shows us why. It works the same way from the side. Only now from the side it shows us how a close object looks taller than the same object, or even a taller object, farther. We learned this at the beginning of this course. Far things diminish, close things enlarge. This is a science. In fact, if we know how to use it, the picture plane helps us solve pretty much any perspective problem, including the one I've been promising, where to place vanishing points exactly. And the full course is 20% off with the code Summer Sale at Proko.com. 1-point setup. Let's place this in 1-point perspective. The viewer looks right at it, face on. One set of lines, the z-lines, recede to their vanishing point. Here's why. When we look at it from above, we see that only the z-lines go away from the viewer, or rather from the window through which the viewer looks. Vanishing point, that way. X-lines just go left and right, like the picture plane does, parallel to it, left and right. Therefore, they go left and right on the window. The up and down lines are similar. They don't go to vanishing points. A side view shows why. Y-lines go up and down like the picture plane does, parallel to it, up and down. This is a 1-point setup. Only one set of lines goes away from the window. Let's go over that again. From the side, we see that the up and down lines do not go away from the window. From the top, we see that the left and right lines are all parallel to the picture plane. Now, that's how it works in 1 point, but as soon as that thing spins a few degrees one way or the other, the X group no longer runs parallel to picture plane left and right. It veers oh so slightly or seriously away from the face of the plane. Two different setups. In 1 point, X lines line up conveniently with our little window. In 2 point, X goes from width to depth. 2-point surprise. Now for a major revelation in the history of technical drawing. The direction these lines point will show us exactly where to put vanishing points. Understand this. In a view looking straight down on the scene, if we run lines from the eye of the viewer parallel to the lines in the scene, they land on the picture plane left and right where the vanishing points will land. That is a breakthrough discovery. So let's go back over it again. We want to place the right vanishing point for this. We spin it to any position, and our viewer, projecting a parallel line, will find it right here on the window. It's a fact. And the same thing will happen on this side. Let's review it again with symmetrical points. If we place the object at 45 degrees so the front corner lands in the center, the vanishing points will be the same distance from the center in perfect symmetrical 2-point perspective. We saw this before, remember? Only this time, it's not isometric. The lines are converging to vanishing points. We can put that to use. Watch this. If we move the viewer up close, the vanishing points come closer together to give that wide-angle effect. And the fun will begin. This is the effect you'll find in our Zolly app. With a smorgasbord of objects on your phone or computer, you can play wide-angled wildness with less concern for vanishing points and more awestruck inspiration at the strange and serious swelling of proximity. You can get it at Proko.com/Zolly. Now, back to the science that makes it so. The value of picture planes. This is a long way away from freehand drawing, but this is the science behind it, worked out a long time ago based on the viewer's eye, seeing an object's points placed on a window, 1 point at a time. No need to do this. This is an obnoxiously slow way to draw, but we care because it shows us the secrets behind the illusion. The picture plane explains from the side how we might look down at a scene and up at a form. It shows why we have more than one set of vanishing points when objects spin. And it shows us not only where their vanishing points go left and right, but for that matter, up and down. But it also allows us to draw plan projections. That means we can take any top, side, and front view of an object and draw it precisely in 3/4 view. In Premium, I'll show you one dot at a time how to project a plan. Right now, I'll give you a preview. It's sort of a puzzle. Here's how you draw an accurate 3/4 view from orthos. It happens in 2 stages, plan and projection. Plan stage. Place your top view behind the picture plane in any position you like. Then place the viewer far enough back so that a 60-degree field of vision includes the whole object. That protects from distortion. We'll make a big deal of that field of vision when we choose to distort things for fun. For now, just believe me, 60 degrees keeps it safe. Next, we run laser beams from corners to the viewer's eye. Each corner places a dot, left and right, where the laser beam goes through the picture plane. Remember, this looks straight down at the whole scene. Seeing that picture plane from the front will reap the rewards of our work, but not yet. You might want to take a moment to think about what we just did. That was to place crucial points like corners where they land left and right on the picture plane. Press pause if you need to. Be sure you understand that before we move on. That gave us position of left and right points, but it didn't give us the vanishing points. Now for the vanishing points. Remember how we did it? Run lines from the viewer parallel to the lines on the object for which we are seeking the vanishing points, and there we are. We now know left and right where those vanishing points go. We're getting some useful information here. We're going to use it. Next comes the part where books on perspective can confuse you. We now change the view. We've done the plan stage, looking down on this world. The next stage is not looking down. Watch this. The next stage assumes that this picture plane seen from the top has swiveled to face us. In a projection, we draw that front view separately, usually below the plan. The projection stage brings these marks down to place lateral positions left and right precisely. Remember, top-down orthos show width and depth. Pay attention here. When depth swivels, it has a little width on the picture plane. Left and right mysteries solved. Now again, I warn you, don't go on if this didn't make sense to you yet. We've been talking about how every point left and right can be figured out through this top-down method, but it tells us nothing about height. Let's move to that if you're ready. Let's move to height. First, we choose eye level, which means place a horizon. That places vanishing points at their height. And fill it all in by connecting dots as the lines going off to the left go their way and the lines going off to the right go their way, and we've projected the plan below us. We could have put it above us. Same process. This is how we did it. One more step for the height of the object. Since that plan view didn't show height, we line up in ortho, a side view or front view. It must show Y lines, pasting it on the window to transfer those height lines into that world. That is projection, tracking those unforeshortened heights into that world so that they look true back there. This is how we project orthos into three-dimensional drawings with no guesswork. If you wanted accuracy and precision, your time is now.
Your time is now.
Give it a try. If you struggle, I'll help you in Premium. I'll show you one dot at a time how to project a plan. There are still a few more days left to take advantage of the Proko summer sale. Every course, model pack, and brush pack on Proko.com are all 20% off if you enter the code SUMMERSALE at checkout before July 6th when it ends. See you there.